is car collisions. So the question is, oh, okay, let's check and see if this works. Movie concussion makes a good deal, it puts a great deal of emphasis on jerk itself.
Hey Rachel, please help me find out what happened to you. I need your help. What the hell is going on down there? The dead are my patients. I treat them with respect, but you have to talk to them? You need to touch somebody alive every once in a while.
The interesting thing about the movie, I don't know how many of you guys seen it. If you haven't seen it, watch it. Every single movie that we discuss can potentially become extra credit if you were to watch it. All right, you're entitled to 3 extra credit percentage points in this class, in this course. And obviously, extra credit means something if you're a borderline. At the end. 140 Gs for a fraction of a second is what you can survive under extreme constraint. All right, 140 Gs for a fraction of a second if you're averaging 140 Gs. If it's instantaneous impact, meaning if it's instantaneous acceleration, maximum acceleration is your measured maximum acceleration, peak acceleration. If it's 250 Gs, can you survive something like that? How about 300 Gs? Can you survive something like that? The answer to that question is yes, of course. We're only dealing with the average acceleration. Your peak acceleration could be 300 Gs, 350 Gs. Is that survival? Of course it is survival. How do I know that it's survival? Because that's what the boxers experience. When somebody punches you in the face, your instantaneous acceleration is going to be around 250, 300 Gs. Football players, likewise, experience the same thing. It gives you concussion. It causes small bleedings in portions of the brain. So the blood moving in the opposite direction of the acceleration usually rips through the small veins and capillaries in your brain. So it causes bleeding in the brain.
I think more about why people die. That is all I do.
Mike Webster had abandoned his family, slipped into financial chaos and homelessness.
The whole town was out of work. He was the guy who gave us hope when there really wasn't hope. Cardiac arrest, maybe how he died, but not why. Mike, I can't do this alone. I need to tell the world what happened to you. My God. I think I found a disease that no one has ever seen before. They use me here as a weapon. You have to keep going. In order for me to keep going, you all have to die. Unfortunately, that's already happening. Families are being destroyed right now.
Molly's gone to the press now.
It's A1 front page, New York Times. If I continue to speak, things could get very difficult. No one will blame you if you stop. No one is stopping anything. What's happening now? What do you think they're doing to you? That's nothing. Let it drop it, or they'll be doing your autopsy, Mr. Amala. Doctor, you're in war with one of the biggest corporations in the world. You continue to deny my work. Your men continue to die.
Tell them what's really happening.
Tell the truth. Tell the truth. I think you're being an American hero. You're not even an American. That's even better.
All right, so the concussion deals with what happens to the brain. And as far as the maximum acceleration is concerned, because it is your peak acceleration, because it's instantaneous acceleration, it can be more than 140 Gs and it's still survivable. We only focus on the average acceleration. When do we focus on average acceleration? We focus on average acceleration when the acceleration values are varying. Meaning that if there's jerking motion, that's when we use average acceleration. That's what it means. All right, pick out the best answer. So what do we know? During a car crash, what happens? Acceleration changes in time. So which means that the C is the best answer for that. All right, so in the jerking motion formula, the initial and final accelerations are those the average accelerations, uniform accelerations, instantaneous accelerations, or average decelerations. In every single formula, on the right-hand side, you always have the measured values. Measured values will always be on the right-hand side, and the average values will be on the left-hand side. Measured values are your instantaneous value. So what's changing is the instantaneous acceleration. So C is the best answer for that one. So how do we make motion predictable if everything is chaotic? Just about every single motion in real life is chaotic. All right, so just about in every single motion, the acceleration is going to keep changing. So how do you make motion predictable? You make motion predictable by eliminating jerk from motion itself. So what do you have to do? Just get rid of jerk. Get rid of jerk. Get rid of jerk. How do you get rid of jerk? How do you make this zero? You make this zero by making sure that there's no change in acceleration. All right. So you got to make sure that there's no change in acceleration, which means that you fix the acceleration to a constant value. So if you fix the acceleration to a constant value, if you make this constant, if the initial and the final accelerations are the same, then the motion becomes predictable. So what happens is the motion becomes predictable. When we talk about predictable motion, here's what we mean. Two things about this motion will become predictable. Location is going to become predictable, as well as the speed at that location is going to become predictable. All right, so the location as well as the speeds will be given to us by three formulas. All right, so those are the three formulas that we will discuss. All right, so if you make acceleration constant, this becomes 0, only if the acceleration is constant. And then the three things about this motion will become predictable. We will get to use the same terminology as we did before. This is your initial velocity. This is your final velocity. Object is going to be accelerating in the forward direction while traversing a distance along the x-axis, and this is the amount of time it's going to take for it to traverse this distance. All right. First formula is going to locate the object for you at a given point in time. Second formula is going to tell you how fast the object is moving at that time. And then the third formula is going to tell you how fast the object is moving at that location. That's it. So we got three formulas describing the motion. The first formula is going to locate the object for you at a given point in time. If it's been 8 minutes, the space shuttle should be 180 miles from the surface of the Earth. If you know the time, you know the location. That's what it means. The second formula is going to tell you how fast it's moving at that time. So you know the time, you know the speed at that time. If it's been 8 minutes, the space shuttle should be moving at 17,500 miles per hour. Third formula will tell you how fast it's moving at a given location. You know the location, you know the speed at that location. If the space shuttle is located 180 miles from the surface of the Earth, it's got to be moving. It's got to be moving at 17,500 miles per hour, provided that you fix the acceleration. You got to fix the acceleration. If the acceleration is fixed, position becomes predictable, and the speed becomes predictable. Those are the two things that become predictable: speed at that time, and then at that location, and the location at that time becomes predictable. You know the time, you know the location. You know the location, you know the speed at that location. You know the time, you know the speed at that time. So two things: location as well as the speed. That will become predictable. All right, so it's called uniform motion. Uniform motion is predictable motion, which means that the acceleration is constant. What that means is something is either speeding up or slowing down at a constant rate, or changing direction at a constant rate. If you fix the acceleration to a constant value, the motion itself becomes predictable. That's what it means. So when the acceleration is made constant, the motion itself is predictable. Three formulas that we're using. Number one is obviously, if you know the time, you know the location. Second formula, if you know the time, you know how fast it's moving. And the third formula is, if you know the location, you know how fast it's moving at that location. All right. What's average speed or velocity? So average speed and velocity is measured distance over measured time. Average acceleration is how fast the measured velocity is changing in time. Question number three, if the acceleration is changing in time, what do we call this? It's called the jerking motion. Question number four, how does one make motion predictable? We make motion predictable by fixing the acceleration to a constant value. Question number five, what aspects of motion become predictable at constant acceleration? Location becomes predictable. What else? The speed becomes predictable. Those are the two aspects of this motion becomes predictable. So location becomes predictable, the speed becomes predictable. All right, so now focus on these formulas. You will find the formulas right here under kinematics. So these are the three formulas that we're focusing on. All right, so speaking of this, let's do a simple problem. This is a muscle car, Lamborghini. So this will be problem number one.
To build a Lamborghini Diablo takes 200 hours, compared to 25 for a mass-produced car. The 12-cylinder 530 horsepower engine was developed entirely by Lamborghini's in-house design team. The body shell is molded of carbon fiber and fiberglass, and finished by hand. Its luxurious interior is covered with hand-stitched leather. Lamborghini makes only 250 supercars each year, and there is a waiting list of 8 months to take delivery. After After its careful construction, each car is taken for a 100-mile test drive on the winding country roads around St. Agatha, before being handed over to its proud owner. The Diablo. 0 to 60 in just 3.9 seconds.